Hello everyone, this is Dr. Srinivasan, Professor Department of CSE from RMDEC Engineering College. This session is all about the Ethereum virtual machine, which is essential for executing the code associated with the code. Actually, Ethereum virtual machine is a state-based execution machine. It runs byte code instructions to transform the state from one state to another state. The var size is 2256 bit in UVM. The start size of the EVM is limited to 1024 elements. EVM is a Turing complete machine and it is limited by the amount of case that is required to run any instructions. It supports exception handling like a normal computer and it is entirely isolated and sandboxed. So the execution of instruction by the EVM will not affect the external environment. EVM does not have access to any external resources such as network as well as file system. It increases the security, ensures the deterministic execution, and it allows untrusted code. It follows the big Endian by design. It allows for CACA 256-bit hash and ECC computations. It offers two types of storages. One is the primary memory or in the form of byte array. When the contract finishes the code execution, the memory is shared. Memory is unlimited, but it constrained by the CSE requirements. The second form of memory is virtual read-only memory or virtual ROM. It is used to store the program code. A code copy instruction is used to copy the program code into the main memory for execution. This diagram shows the structure of the Ethereum. So in the Ethereum stack, we are storing all the instructions, and here we are using the program counters to control the instruction executions. And these the instructions are moved into the main memory by the outpost, and this outpost, this the main memory used to support the execution of instructions. So initially, the virtual RAM stores the program code. They are fetched and they are placed in the main memory, and the program counter helps to run the execution of these instructions one by one. And after the executions, it stops the programs, and the stack is used to store the variables values temporarily. So we are having so many types of EVMs, and one of the most popular EVM is WebAssembly. It is developed by Google, Mozilla, and Microsoft. And WASM aims to able to run the machine code in the browser itself. As a result, there is no need to install any special software for executing the um, programs. A joyful universal language for assembly is another popular EVM, and it can compile to various backends such as EVM and WASM. Now we see the important parameters that are used to capture the state of the EVM. First one is system state, remaining days for execution, the address of the account that owns the executing code, the address of the center of the transaction, the originating address of the execution, the grace space of the transaction that initiate the transaction, the input data or transaction data, depending on the type of executing agent, the message call, the address of that code that initiate the code execution, the address of the center in case of code execution, address of the account, the value or transaction value, and the code to be executed as a byte array that the iterator function picks up in each execution cycle, the block header, the number of message calls, then the permissions to make modification. Thanks for watching.